Hello, Peter here. Last time we prepared our shadow container, level data actor and blob shadow component. And now we can start doing some of the cool stuff. So let's start immediately. Open the SDL blob shadow component from your blueprints folder. We're going to begin with setting some stuff up in the event begin play. Let's remove this comment and give it a bit of space. So the first thing we need to do is to get our SDL level data actor. We're going to do that by get all actors of class. Then we select the class, and that is going to be SDL level data actor. Just select that one. Now this will return an array of all the instances of that class, but we only have one, so we can safely just get index 0. So do a get, an array get here, and leave this at 0. Now we can promote this immediately to a variable as well, and let's call that one SDL level data. That will give us the set node. But before we do that, I really like to test if it is valid. So let's have the space. Let's check if this one is valid. If it is valid, we are going to set the variable. Now if it isn't valid, we can't do a lot. So what I tend to do for this particular one, because that usually means that you forgot to add a level data actor into your level, and it's nice to get a kind of a warning for it. So just printing a string here and put the text something like you must add an SDL level data actor to your level for SDL blob shadows to work. It is just a reminder for us. We can maybe make this slightly longer so that we don't miss it. So yeah. Then we have our variable and we have the SDL level data. So now we can register this blob shadow component to it, this instance of it. And we do that by register SDL blob shadow. Now the target is the SDL level data, so that's the target for the function call there. And the blob shadow is self. So get a reference to self will do here. Right. I see there is a little typo here. That should be, of course, a SDL, and blob shadow should be with a space. So that's good. You see now what we did in the last episode. It was really needed because we need to have these function calls in SDL level data actor and so on for this all to work. So that was why we had this kind of weird episode last time. Okay, the next thing we need to do, something we are going to need, is the primitive component of the parent. So how are we going to get this? Well, first we're going to do get owner. And the return value, we are going to say get components by class. And the component that we want is primitive component. And this will return an array again, and again we just get a copy of index 1. And this one we will now promote to a variable, and that one is called primitive component. And we can now hook that up like that. Because we need that one many times to get like location and rotation and whatever. That's why the primitive component is really easy to have. So yeah, I think I said index 1. It is of course index 0. It is the first one that I mean to say. Now we need to spawn our shadow container, and we do that by spawn actor from class, and the class we are going to spawn is SDL shadow container. We don't want this container to do any collision or whatsoever, so what we want is always spawn ignore collisions. It's going to be where I'm going to say it's going to be. Well, its orientation and location and so ever, that comes from the spawn transform. So what we need to do is make transform. I think we need some space because there's some stuff that needs to be done. So how are we going to get that? Well, the very first thing, the location and the rotation, we get from the primitive component. So we drag that out and do a get, and then we say get world location, and we can immediately drag out another one for the world rotation. Now that's no magic, just put it into location and put the rotation into the rotation. Now for the scale, we need to do that automatically. The scale is actually going to be dependent on our radiuses, or radii really, I think it officially is. As you maybe remember, our ellipsoid has a radius x, a radius y, and a radius z. And we want that cube, which is going to create the opacity mask that is our shadow, is big enough to contain the ellipsoid that we define by its radiuses. Now the cube we are going to use, I know that it has a size of 100 by 100 by 100. So you could say the radius of it, or the half widths, are 50. So what we're going to do is to take the radius of all these things, divide it by 50 to create a scale for it. Because what we need to do for this one here is to make a vector. And that will become our scales. But first we need to have all these radius. We don't have the variables yet. So let's add them. Grid of variable radius. Oh, sorry. Radius x. The type is going to be a float. And we add another one, radius y, that is now immediately a float, and radius z, or z. So now we can drag them out here, get the radius. And what we do is divide float, and we set this one as a constant 50 and connect up the x component. So let me quick connect up all these things so as not to waste so much time. So that is done. All radii divided by 50 to create a scale. Again, this 50 only works because I know that the cube we're going to use is a cube that has sizes 100 by 100 by 100, and that the scale for that one is 1. So if this radius is going to be bigger, it is going to reflect the new scale, or smaller by the way, reflect the new scale by dividing it by 50. I also made the radius x, y, and z public. And I gave them the default value of 50. It doesn't matter what kind of default value you put in there, but 50 seems logical here. Often you need to first compile your blueprint so that you can set the default values. So that is the spawn fixed. The next thing we do is to save the return value, the actor that we just spawned, because I like to also destroy things when we are cleaning up. So let's promote this one to a variable and call it shadow container. Now the next thing we need to do is to access the static mesh component, and I opened already the shadow container just so I could remind you of how that was. Yes, the shadow container we just created and did nothing with, and it has, because it is a static mesh actor, a static mesh component, and this is the one that we now want to set with a certain mesh. And to do that, we need to call set static mesh. It's very nice. It already creates this little thing, which gets from the target the static mesh component. Well, the target is our actor that we just spawned. So now we need to set what kind of mesh we want to set there. And that is the cube. Now I'm using a very specific cube because I know the sizes and the scale are right, and that is one from the engine option. So in view options you must make sure that show engine content is checked. So now we select cube, and we need the one that is engine basic shapes, not the one that is engine meshes, but the one that is engine basic shapes. And you see it is 100 times 100 times 100. Of course, you can create your own cube. A cube is very nice. It doesn't have a lot of vertices, but you see this one still has a lot more than really is needed. So to optimize, you could create your own static mesh that has the minimum vertices that you need. But you need to make sure that the size of the cube and your calculations for scale are consistent. So let's select that cube. Now we want also to save the static mesh component as a variable. So I'm going to promote this one to a variable, and we will call that one static, the shadow container mesh component. Shadow container mesh component. Bit of a mouthful, but at least there is no discussion over what it is. And simply set that one. The last thing we need to do with this is to set the relative position of this mesh. Set relative location. Well, the target is that thing itself, the mesh component. The new location can be 0. It's going to be at the origin of the shadow container. You're probably starting to see that what we are doing here is exactly the same as what we were doing in earlier episodes in the editor, like creating a cube, putting a material on it, and so on. This is exactly what we are going to do, is to put a material on this. And now we need our mesh component, and get it. And we're going to drag out from it and say create dynamic material instance. The element index is 0. The source material is, of course, our m_blob shadow. Now this material we're going to use a lot, so we want to promote it to a variable, and I'm going to call it dynamic. So what we need to do now is to set the parameters that we created in our blob shadow material. So what the first one we're going to set is the shadow color. So let's create a variable called shadow color, and let's give it the type of linear color. Drag it out, get the shadow color, and also let's drag out our dynamic. I know it's there, but we're going to need it so many times. So we're putting dynamic there. So from here, set vector parameter. Now, set vector parameter value, you will see two of them. You need the one that says set an MID vector parameter value. That is the one we need. Now, the shadow color goes into value. Dynamic is the material, the dynamic material instance, and that is going to be the target. And the parameter name is shadow color. Now, it is very important that you get those names right. So I suggest that you as well open in the materials the blob shadow as well, so that we can use that as a reference. And of course it are these parameters. And now it is shadow color. So this name must be exactly the same. Let's go back to our one here. The next one we're going to do is radius X. So drag it out, get it. And this time we are going to set a scalar parameter value, and again always make sure you take the MID version of it. This one goes into the value. Now, and here we're going to have to find a way to not clutter this up too much. So a good way to do that probably is to drag out this and create a route node. Add a route node. They never seem to really want to be straight, but we can now drag this one into target. And the parameter name for this one is radius X. And again, very important that it is the same as in our material. Now we've got loads of them, so I'm going to wire this all up so that you don't have to watch that. So that is the monstrosity of our whole event begin play. These things never are beautiful, but I try my best to make it sort of organized by using the route nodes. Feel free to format that in your own way, but I think it is understandable as it is now. As you see, I added a lot of the variables that we needed. We already had radius X, Y, and Z. I added the cutoff, hardness, max opacity, and rotation. They are all made public, and I've organized them all together here. They all have default values. Cutoff is 56, hardness is 1, max opacity 100, rotation 0. We don't have the object rotation here because we don't need it here. That is going to be done in the SDLTix. Oh, I see that shadow color is still not public. Of course, that's also something we want to set in the editor. And we want this to be on top there somewhere. The default value for that is black, which is perfectly okay. Yeah, that's good. So yeah, that is not a nice job to do, but it'll do the trick. So before we end this episode, there is one thing I want to do. I already made a bit of space here. You see, these are down here, because we now have the event begin play. I also want to have an event end play. Oh, sorry, where is the... Yeah, make it here. End play. because we need to clean up. And obviously the very first thing we are going to do is to unregister the blob shadow from the SDL level data actor. The easiest way is to just drag this one in, because then it has the context right, and then you can say unregister and it will come up with our function there we created in the previous episode. And what are we going to unregister? Well, the blob shadow, and that is self. So get a reference to self, and that will do the trick. Now we also spawned an actor, the SDL shadow container. We need to clean up that one. So let's drag out the shadow container. And destroy actor is the one that we need. But let's first test if it's still valid. You never know, maybe it already got destroyed. I'm still not completely 100% on the life cycle of some of the Unreal Engine stuff. If it is valid, we are going to destroy it. If it isn't, well, then it's gone already. So that's the cleanup done for the event and play. In the next episode, we're going to look at the SDL tick, where the real stuff is happening when we are playing the game or doing whatever. So yeah, not a beauty, but it does the trick. So see you in the next episode, guys. Bye bye. Hello, Peter here again. Just wanted to say thanks for watching this video. Please let me know what you thought of it in the comments. Below there are links to other episodes in the series, and don't forget to subscribe so you are the first to know when the next episode is up. Thanks again for watching, and see you in the next video. Bye!